All right, hello everyone. Welcome to the What's New in OpenShift for OpenShift 4.10. I'm Rob Sumsky on behalf of the entire product management team. We are here to tell you all about it. As a reminder, what's cool about this is some of our Red Hat focused field enablement, but we also stream it live for our customers. So you get to experience all the goodness at the exact same time. A reminder today, we're going to talk about the entire Red Hat Open Hybrid Cloud platform. It includes everything you see here. OpenShift Platform Plus is the package that has all of this in it, and it covers things all the way from multi-cloud, multi-cluster management, to all the security tools you need for all those clusters, getting content out to them through a global registry, all the data services, plus all the developer application platform services that you come to know and expect inside of OpenShift for building your applications, getting them out there, keeping them secured. So we're going to talk about all of it today. We've got the PMs from each of these areas to talk about what is happening specifically in 4.10 for those areas. Looking at 4.10 at a quick overhead view, we've got a bunch of new installer platforms. So our IBM Cloud IPI is going GA, as well as Azure Stack Hub. And then following quickly behind that is Alibaba Cloud as a tech preview. This is a pretty mature one, so definitely test it out, and that'll be GA pretty soon. Also GAing today are ARM instances for Amazon is GA. We've been testing this out. It's been well received. So please take a look at that. In the automated operations bucket, we've got a bunch of cool things here. So we covered last time how our EUS policy is changing. And so 4.10 will be one of those EUS releases, and it'll be one of the times that you can do this reduced worker reboots during an EUS upgrade. And so we'll talk about that, as well as some other changes to cluster upgrades around reducing risk. So if there is maybe something we're investigating on a specific platform, we may want to suggest that folks don't update on that one, but otherwise roll forward and all the rest. So new features there, as well as for our disconnected clusters, how you mirror content and run that stuff in your disconnected environment. We've got a bunch of great changes there. On the workload side, a bunch of new compliance profiles for our compliance operator to keep you secure with your government regulations. Sandbox containers are GA, so if you need a little extra isolation, you can wrap your workloads in those. On the networking front, two exciting things. One is you can now bridge your virtualization VMs into a service mesh. So if you have VMs and containers that want to talk securely together, they can use your service mesh. And then if you want to expose services outside of your cluster, with MetalLD, you can now have BGP routes for those extra services, get everybody connected into the content. So there's a whole bunch more, so stay tuned, and we will dig into it. As you know, we ship a new version of Kubernetes with every OpenShift release, and so we're shipping 1.23, today. And a cool set of new features there that we're going to pick up. Clusters are going to default to dual stack networking. So this is a feature gate that was there upstream. It's now being removed, so it's on by default. This has actually been GA and OpenShift for a few versions now since 4.8, so no change for us there. Pod security is graduating to beta. So this is something where we're doing a lot of upstream contribution. And so our plan here is to support the upstream pod security admission work when it comes in and goes GA. And we'll continue to support our SCCs side by side. And so you can use the new stuff, you can use the old stuff. We got you secure the entire way through. And if you've heard us talk about our CSI migration work, that continues upstream. So this is replacing storage drivers with the corresponding CSI driver versions. We've been doing this work in OpenShift. We will seamlessly migrate to this in the future. And so we've been watching this one pretty closely. And then last, on the software supply chain front, a ton of news about this recently. So Kubernetes has put some attention into their own release process and have gotten level 1 compliance. We also put a lot of emphasis on this on the OpenShift side and Red Hat wide, to be honest. And so we're excited to see any innovation. So yeah, we've got Cryo 1.23 coming in, Kubernetes 1.23. Then the roadmap, I'm not going to go over all of this. Feel free to pause your video or take a look at these slides when they end up on the Red Hat website. But we've got a ton of work going across the entire platform here. What you see in Q1 is most of the stuff that we're going to talk about today. And then a bunch of stuff going on for Q2. You'll see a ton of investment in our hosted platforms, app and dev services. Of course, the platform continues to grow forward. and then into the second half of this year and then early next. Tons of work going on, all across the board, pulling in the best of breed from the Kubernetes ecosystem. As always, if you have questions on this, we'd love to reach out and talk to customers directly, and so please reach the PM team. All right, lastly, I want to talk about RFEs. These are our requests for enhancement. We shipped 45 RFEs, and these are direct customer asks that come to us, and you'll see the kind of the top ones here. A lot around network configuration. This is a classic thing. Everybody's network looks different, and so we want to adapt and meet you in your world. So some great options there, as well as debuggability and kind of, the way that we own management of the nodes all the way up into the cluster means that, we can emit some more events to help for debuggability. These are direct customer asks. And then this availability sets for Azure is interesting because, our default is we're just going to go across all the zones in a cloud region that you give us. Some of those regions don't have enough zones, and so this is adapting to that with some of the availability sets in Azure to still get you an HA cluster and maybe a little bit of so really cool to see those. Like I said, there's 45 of these. This is just a subset. So OpenShift keeps getting better. And with that, let's jump into our spotlight features. So I'm going to start handing it off to the PM team. You're going to hear from the best and brightest, and I will start off with Adil.
Hello, everyone. My name is Adil Zalouk, and I am the product manager for OpenShift Box Containers. The good news is it's going from tech preview to GA, so mark that. However, what is Sandbox Containers? For the first time people are hearing about it, it's an additional optional runtime that you can use for your additional or third-party applications, or for the applications that require extreme and stringent levels of isolation. You get that for free in OpenShift when you install the operator, the OpenShift Sandbox Containers operator. So what did we do from a feature level perspective in 4.10? We added three most important or major features. One is instead of you having to check manually your node eligibility for installing Sandbox Containers, the Sandbox Containers in the backend relies on Kata containers, and that is also using virtualization. So things like VMX needs to be there. We rely on hardware level virtualization, so we made that easy for you. So you can just check on our custom resource that you want to make sure that the nodes are eligible for installing Sandbox Containers. And in the backend, we use the node feature discovery operator, and just make sure that you have that checked, and the installation will proceed once all the nodes are eligible, or the nodes that you chose for Sandbox Containers are eligible. The second more important one is the metrics. So we're adding more metrics, not just the metrics that you get for free, because Sandbox Containers give you its containers. They're running the same way as normal pods. We add more deep down stack level metrics on the Kata agent, on the VM, CPU, and memory, lightweight VM in the backend, the number of VMs you have in your clusters, so you get additional visibility. And in the future, we'll be adding more and more metrics for you to get visibility, and for us to help you get better in deploying your workloads. And then finally, we have increased the debuggability options. So we're adding more and more logs. Again, the same we're doing with metrics, we're doing with logs. So now, if you set the log level to debug, you get logs across the entire stack, including the Kata stack log, the Kata runtime logs, QEMU logs, VirtuoSD, and more. And this does not just help you see what's happening underneath in the background, but also helps you when you're facing problems, when you're raising support tickets. This will be of great help. That's all what I have. So thank you, and I'm going to pass the ball to Subin.
Hi, I'm Subin. For OCP 4.10, we have a quicker, safer, and less disruptive upgrade experience when you're going from extended update support version 1 to another. In the diagram, you'll notice node 1, which is on OCP 4.8, skipping version 4.9 when it upgrades to 4.10. So what happens is that you have a safer upgrade and you have a quicker upgrade, which involves just a single reboot of the worker node. We also have a upgrade aware scheduler, which steers these rescheduled pods from 4.8 to available 4.10 worker nodes. In this way, you have a quicker upgrade process. And also the pods restart less frequently, so there is less disruptions to the workloads you have. Over to Daniel.
Thanks, Zubin. Let's talk about disconnected. We know that some of our customers really want to deploy OpenShift in environments without a direct connection to public Red Hat services like the Red Hat registry. And they're doing this mostly in on-prem environments in their own data centers, but also in some of these cloud environments. And for these deployments, which we call OpenShift disconnected deployments, in 4.10, we are really delivering a lot of simplifications and streamlined tools to help install these disconnected clusters. So in order to install disconnected, you kind of need two things. First, you need all the images, container images that OpenShift is using as part of the installation and at runtime. And you need a bucket to store them all in before you actually carry out the install using the OpenShift installer. So the first thing we did is we actually already released the solution to the bucket. It's called the Mirror Registry, and it's essentially a simple installer that gets you up and running with a streamlined all-in-one instance of Red Hat Quay on a system with RHEL 8 installed and Podman available. This alleviates the need for any kind of stopgap solution using upstream registries to store your content in. And it's actually available as of today at no additional cost for all OpenShift customers. Now you need to kind of populate this bucket with the content that OpenShift needs to run and install. And this is content from a variety of sources and different types. It's, for instance, the OpenShift core images of the core cluster infrastructure and the core operators, but also the optional operators managed by OLM to add the layered products to it, as well as any kind of custom images or Helm charts that you may need in your disconnected cluster. And we've had previously asked you to use several different tools, each with their own documentation and different command structure to carry out the different steps to initially create the mirror and then also to maintain these mirrors. What we are doing with the new solution for this, which we call OC Mirror, is centralizing all of these steps, all of these content types into a single command of a single binary, which is actually a plugin to the OpenShift command line client. So OC Mirror is really your one-stop shop to mirror the OpenShift images, the operator images, Helm charts, and any custom images. And you do this essentially in a very declarative, Git-friendly way by expressing all your desired OpenShift releases, as well as operator catalogs and operator releases in a text file. And you feed that text file to the command line utility called OC Mirror. And what OC Mirror will do is mirror all this content in a single step, in a single command, in a single transaction. And what that gives you is your first mirror to carry out the installation of your first disconnected clusters. And the tool is very smart about this. It's not just a simple downloader, right? It will actually take advantage of things like layer sharing and deduplication, as well as allow you to trim the releases of OpenShift and operators and catalogs that you really need in your disconnected environments to really just what you want in order to reduce the amount of data that needs to be downloaded. But what you also want is for these disconnected clusters to keep receiving updates, right? And in order to do that, you need to keep the mirror up to date. And OC Mirror actually does that as well. And it does this by simply rerunning the tool with the same configuration, again, in something as simple like a cron job. And it is very smart when it does this. So it will actually take a look at what you have already mirrored the last time you did the initial mirror, and it will figure out what has been released in the meantime in terms of additional OpenShift releases, new operator catalogs, new versions in those catalogs, and new channels. And it will start to download all of this in order to get you an update path that you can walk along to update to the most recent version of OpenShift and the desired operators that you have. You need to basically do nothing else than just feeding it the same config file that you did earlier, and it will figure out what intermediate releases, if any, need to be downloaded in order to upgrade. And it will also do dependency resolution on the operators that it is updating, resulting in a disconnected experience that from the perspective of updating cluster is very close to what you would have if the cluster was connected. And with that, I'm handing over to John.
Whoops, might have lost Doran here. I'll cover this really quick. So we've got 3 new compliance operators. So this operator runs in your cluster and can enforce these 3 standards. So we've got PCI DSS, FedRAMP moderate, as well as the NERC CIP for kind of the telco and kind of electrical type appliances. So this is really cool. It's enforcing these standards where we can inside of the cluster itself to remain in compliant. You can also deploy this across a fleet of clusters and have them all remain in compliance and get reports on them through ACS and ACM. All right, so I'll hand it over to Duncan.
Thanks, Rob, and hello, everyone. I am very sure that you've all heard about the buzz going around about ARM-based systems, the new systems from Apple, the offerings at AWS, and all those nice, juicy servers that are coming to market now that you can go out and buy. And it really does feel like this year is going to be the time that ARM will see major adoption. And at OpenShift, we always want to give our customers the choice to run your workloads and your applications on the best infrastructure. So I am really pleased to announce that we're going to have general availability of OpenShift on ARM in the 4.10 release. In this release, we're going to let you run on the latest AWS ARM-based instances, as well as those nice, juicy bare metal servers that you have bought or you're going to buy. Of course, OpenShift is such a rich platform, and while we've got all the core pieces in place, we've still got some work to do on those surrounding nice, juicy add-ons, but expect those gaps to be filled really quickly. We're seeing really nice results there about bringing these things along. Out of the box, you'll probably only be able to use EBS and NFS. We might sneak EFS in there on the storage side, but on the plus side, big kudos to the login and ACM teams. They've pulled out the stops, all the stops, and they're going to have some ARM functionality around the same time we GA on OpenShift as well. For those of you looking at hardware, as always, we recommend using the certified systems on the RHEL HCL. But the great news is we've kind of opened things up, or Red Hat has opened things up as far as choice, and we'll also be supporting you to run on systems that have met the ARM system-ready, server-ready specification. So that really opens up what kind of systems you can buy and run on. So, whatever architecture you're looking at, whatever applications you want to run, you can choose now and run OpenShift in there on top of it with no issues at all. And now, let me hand over to Deepthi and/or Mark Curry to chat to you about Metal LB.
Thanks, Duncan. Metal LB FRR BGP support. OpenShift installations on public cloud providers have always taken advantage of native load balancing services. And up until very recently, we did not have any out-of-the-box native load balancers for bare metal infrastructure deployments with OpenShift. And this is when we introduced Metal LB in L2 mode as a fully supported load balancer for bare metal deployments. And we have further enhanced this in 4.10 by providing support for the BGP mode. With BGP, we can advertise direct routes to Kubernetes services to other BGP participants outside the cluster. So basically, Metal LB running on every node establishes a BGP peering with nearby BGP-enabled routers and tell them how to forward traffic to the service IPs. So for configuring BGP, we need to provide information on address pool for Metal LB to allocate service IP. And this is done via the address pool structure. And we also need to provide information on the BGP session connecting each node to each external router to the BGP peer structure that is seen here. One can also pair a BGP session with a BFT session for faster failover detection. And given that each node acts as a mini router with Metal LB deployment, we do not allow external routers to inject routes into the cluster. And with BGP pure node selector, you can run Metal LB speaker pods on specific nodes by specifying the node selector. And we also have an iBGP, eBGP, and single and multi-hop support with this release. Next slide, please. Thank you.
The Rail entitlement management for image build, this is an area we have been working on the past couple of releases and delivering pieces of that. And the problem that it addresses is that a lot of our customers run image builds on the cluster using Docker file builds. And within that, they want to install Rail RPMs within those Docker file builds. And since every OpenShift container platform customer, OCP customer, is entitled to Rail content, we wanted to make this really easy, similar to how it was in OCP 3 for them. There are three areas that these improvements are applied. One is for customers, how do they get access to the entitlements that they have purchased with OpenShift. The second one is how do they manage access to this. Perhaps they have a multi-tenant cluster. They don't want to expose all the tenants to use these entitlements that they have. And the last bit of how to actually use them in a Docker file build. In 4.10, managing those entitlements, getting them into the cluster, it reaches GA. This is a function that Insight's operator fulfills and Insight team have delivered in 4.10. The cluster reaches out to OCM and downloads the entitlement certificates of the OpenShift subscription that customer has purchased. Customer needs to enable simple content access on their account. This is a one-time thing they do at their account level, Red Hat account level. And from that point on, they can automatically pull the certificates, and Insight Operator manages the lifecycle of these certificates as well, because they get invalidated with any change in the Rail content, so automatically refreshes them to make sure that cluster at all times has access to a valid entitlement certificate to use. This is only available on OCP, not available on OS 0, SAR, and other managed instances of OpenShift, because those do not entitle customers to Rail content. On how to managing access to these entitlements, the work that the build team has done with shared resource CSI driver is moving to take preview, and this operator essentially allows the platform owners, the admins, cluster admins, to control, to share that entitlement that is pulled to the cluster with their tenants across different namespaces, and controlling who can access and who cannot access it. So it gives them a granular control of how to consume, who is allowed to consume these entitlements. And the last bit is once a team gets access to these entitlements, they can mount it inside a build configs through a CSI driver, which will move to tech review, or they can mount the secret that if admin decides to duplicate the entitlement secret that Insight's operator puts it on the cluster, they can mount it as a secret inside a build config or pipelines or pods or anywhere else that a secret can be mounted and used in a Docker file build. And that capability remains GA. The use of the shared resource CSI driver and the use of that CSI driver inside the build config, that remains take preview 4.10 and moves to GA in the following releases. Next slide, please.
Hey everyone, Ali here from the console team. So big news, really excited to share with you all, multi-cluster capabilities have finally come to the OCP console. What does this mean? This means we now have a single interface to view your fleet and to drill down into the details of each cluster or app running on individual clusters. So you can now easily switch context between each of your clusters and come up a level to get a glance of your fleet. Essentially what we're doing is we're giving you the best of both ASIM and OCP UI brought together. So how does this work? You start with a single OCP cluster, then you have essentially two options. You can install the multi-cluster engine operator standalone. This MCE operator is new and will enable the cluster switcher, the basic cluster management capabilities, which gives you the ability to either create, update, or destroy clusters, and gives you the cluster inventory list. The MCE operator is included with your OCP subscription from now on. So the second option you have is you can install ACM, which will give you the entire cluster lifecycle management stuff you get from MCE, plus all the great stuff like policy, config management, multi-cluster network, multi-cluster application deployment, and much, much more. So really excited to announce this. This will be tech preview in 4.10. You'll need a feature flag to enable it, and expect to see a quick start to help guide users to enable this new multi-cluster console. Next slide, please. So also new in 4.10, dynamic plugins will be offered as tech preview. From the console team, we get a lot of requests to be able to come and customize the OCP console experience. Previously, we had a really prescriptive ways of updating the console using either console CRDs, like the console link CRD to add a link to the UI as an example, or OLM descriptors for customizing your operand creation. Now with dynamic plugins, we're giving our partners and customers a lot more flexibility to tailor the UI for different personas or even add an elevated experience for your service and offering. So a couple of big things we'll allow people to do is you'll be able to come in and update an existing perspective, which means you could add new nav items, new flows, new pages, actions to existing pages. This would be either done in the admin or dev perspective. The other option that we're giving our users, is to add new perspectives. If you want to create a persona or task-based perspective that's completely standalone, you'll have that ability to do that as well. A little bit about the tech behind this. This is essentially based off Webpack 5 module federation, so you write your own Webpack module federation piece. It's built with all the Patternfly 4 components. Plugins are dynamically loaded during runtime and disabled and enabled via UI console. Plugins can be updated independently of the host application. This means if you have an operator that's delivering the plugin, you could do this at any moment. You don't have to wait for a new release or update of the OCP console. And then finally, plugins enable and provide extension points for your whole perspective. So currently, we've added a ton of extension points like I talked about, adding nav items, pages, actions to the admin perspectives. But for example, we actually used ACM to provide the multi-cluster view in OCP console. And what that's going to do is they could go ahead and add all their extension points to allow people to come extend the multi-cluster view as well. So that's going to be really nice. So you could also expect a getting started guide to come soon. And then if anybody wants early access before the release, contact me. And then I'll give you all access to the samples and template repo available. Next slide, please. So you asked, we listened. Every OCP release, we try to address some of the most popular RFEs. Here are the ones we got to this release. So pod debug mode right from the UI. This will allow you to run exactly the same thing as OC debug pod right from the UI. It'll start up an interactive shell, which will stop the pod from crash looping. It'll allow you to check your environment variables, config files, allow you to access your logs and events right from the console, which is fantastic. The next thing we added is we updated the user preferences. One of the big asks we got was to be able to hide user workload notifications to the admin, so you now have the ability to hide that. Also, we added the default method for route creation. So if you want to, make sure that secure routes was the default option selected when you're trying to create a new route, that will be enabled as well. And then finally, we added the ability for non-admin users to come in and see their quota usage via the applied cluster resource quota. So that is now available to non-admins in the UI. All right, next slide, please. And I'm going to be passing off to, I believe, Siamak.
Right, thank you. So on OpenShift builds, on the classic builds, already mentioned related to all the work that has happened around enabling the rel and tactical management with the shared resource asset driver and mounting that inside the build configs. ShipRite builds is the next generation build that we are moving on to as evolution of classic builds. And within this release, building from local source is enabled. So this is extremely helpful for iteration locally before submitting something to Git repo or creating on a cluster. You can use the ship CLI to upload the source from current directory into a build that executes on the cluster. Custom annotations are supported now on the output images. You can decide and specify what annotations should be available on an image that is built through ShipRite, and volume support is another aspect that is added inside the ShipRite build as well within this release. Next slide, please. OpenShift Pipelines 1.7 will be available alongside 4.10. There are quite a lot of capabilities that are added within this particular release. Pipeline as code will move to tech preview. Pipeline as code is enabling GitOps workflows for your CI, so the customer can put their Tekton pipeline in a Git repo, and that's the sort of that's the source of truth for the pipeline. And every time an event comes from Git commit or pull request, they can execute that pipeline on the cluster. Provenance for both images, and task run is another aspect through Tecton chains and signing through the SigStore project, being released as tech preview. We are transitioning to bringing the ability to create a set of tasks for developers and DevOps engineers on the cluster to our customers. So Tecton Hub is brought onto the cluster, is optional at this point. The customer can enable it, add their own task in there, and we are working on bringing integrations in the tooling that we have to this instance that customers can run for themselves and have full control over what kind of tasks they want to expose to their development teams. Another capability, important one that have been on the horizon for us for a while is that in this release on OCP 4.10, there is the ability to run tasks or the tasks from pods really in the user namespaces, which allows those tasks or those images that are required to run as root inside the container to be run in the user namespaces as non-root on the host. So it addresses one of the criteria that some of our customers, or a good portion of them, have, that they do not allow any privileged containers to run, and things like S2I image and Dockerfile builds require that because they use build-up. So we have the ability in this release to run them as non-root without any particular privilege or SCC or service account, just using the default service account and just run it in the user namespaces. There are improvements in the trigger project in Tecton so that we can get the events of how, if a webhook has come from GitHub and failed within the namespace, that the trigger and the pipeline is running, so that it makes it really simple to access that kind of information and figure out why a pipeline, for example, is not triggered if you have committed to the Git repo. We heard from Adel that OpenShift Sandbox Container has moved to GA, and we have verified that it works with pipeline. That's one of the use cases for customers that require higher level of isolation within their CI pipeline. So that also works as the last screenshot at the bottom that you see. It shows how that is enabled in a Python run, for example, to use the kata runtime for executing the pipeline. And there are a diverse enhancement within the dev console around the pipeline UI. We support now multiple pipeline templates when a user developer is importing an application into OpenShift. That's the top screenshot, and that's the ability that allows platform owners to have prescribed or predefined supply chain templates also for their tenants, that they can add it to the platform as a template. And when the tenant is importing an application or namespace, they have an option of choosing the pipeline. Before 4.10, there is a single pipeline that they can provide for the entire platform. Now there's the ability of having multiple and allow the tenant to choose. When through that import flow, an application is on OpenShift, added to OpenShift, now a webhook is also automatically created for it that can be easily added to the GitHub provider and to the Git provider and have the pipeline execute on Git events. Previously, this was a manual thing that the user had to do post importing the application. And within the Tecton Hub integration that exists in the pipeline builder in Dev Console, now we have links to the documentation of those tasks that can jump onto Tecton Hub and read more about the task and how it can be used within the pipeline. Next slide, please. With OpenShift GitOps, OpenShift GitOps 1.5 will be released alongside 4.10. This provides Argo CD 2.3 that will be released quite shortly. There are 2 new generators that are added in application sets. This allows, for example, generating the application for every pull request that comes to the repo. This is really useful if you want to automatically deploy the application on pull request to a particular namespace and be able to test that and decommission that. So it allows us to have that kind of dynamic application creation for pull requests. And another aspect is another generator is the ability to merge multiple generators. So maybe after an application is created for pull request, you want to override some attributes of that application from a Git repo, a list in a Git repo, or from a different type of generator. So it allows a way to merge the result of multiple generators and generate the applications that you need for a particular event and dynamically add applications to Argo CD. There are some improvements done also for making it easier to deal with resources that are not completely GitOps compatible. So for example, there are objects on OpenShift and on Kubernetes that some attributes of them are managed by the operators. So when you create the object, an operator comes and mutates those fields. So now there is, we have always had support to ignore these attributes. Now there are new ways, more advanced ways of ignoring them through managed fields, for example. And if you look at some of the objects on OpenShift, you see at the topmost there is a managed field attribute, and under that a long snippet of saying what are the fields that are managed by whom, by which operator. So in GitOps 1.5, you can, for example, say any object that is managed by the registry operator, ignore those ones during diffing and syncing, so that obviously it doesn't complain about someone else that operator has changed those fields. Another ability is that previously ignoring fields was only happening during diff, so that Argo CD doesn't complain about an object being out of sync. What happens in this release is that you can also respect those during the sync flow. So for the objects that are or fields that are managed with something else, you can tell Argo CD that the first time that you're creating this object, create this field, but after that point, ignore it in any of the syncs or ignore it in any of the diffs that you do, so that it doesn't show out of the sync, and you don't overwrite that field if an operator on the cluster is changing it, mutating it. And there are enhancements within the dev console also that is added. Health status of the resources. We already had the sync status in the environments view, and the sync status, the health status, that's that broken heart that you see on the slide, is added also, so that it shows if the object is in healthy condition on the cluster. Next slide, please.
Hello, everyone. OpenShift Serverless is based on upstream project Knative, and for 4.10, it will be updated to Knative 1.0, and this is going to be a big milestone for us. We have added some features around eventing for these releases, and to enable developers writing event-driven solutions, one such feature is Apache Kafka-based broker as a tech preview feature. This can maximize Kafka performance persistence and can also avoid event duplication. It will also prevent tight coupling with Kafka because it eliminates the use of Kafka clients by event producers. In the same theme, another tech preview feature is Knative Kafka Sync for OpenShift 4.10. It could store receive cloud events from source, subscription, trigger, eventing construct on a Kafka topic without writing any custom code. Now for our developer experience, a new plugin is being added to the CLI for developing, debugging, and testing, again, event-driven applications by sending cloud events interactively to apps using KNCLI. On Dev Console, a new visualization of event sync has been added, as you see from the screenshot on the left. And another important addition on Dev Console is to make any Kubernetes services as a target output or sync for cloud events from a serverless eventing infrastructure. A subscription or trigger can be added to any kube services available on the cluster to enhance the development experience for EDA solutions. Just want to add that we have serverless functions as a tech preview feature in 4.10 as well. We are constantly evolving this by adding new features and creating better user experience. As of note, various runtimes are available out of box, and it provides local developer experience using Docker and or Podman on Mac, RHEL, and Windows. Please try out these tech preview features. We would love to hear your feedback and the use cases that you're trying to solve with them. With that, I will pass it on to Jamie.
Thanks, Dana. For OpenShift Service Mesh, we're aiming to ship Service Mesh 2.2 this April. It'll be based on Istio 1.12 and Kiali 1.4.7 at least. Going forward, we're looking to keep our service mesh within a release or two of upstream Istio, so accelerating a bit. Istio 1.12 also introduces a WASM plugin API, which will deprecate our existing service mesh extensions API. As the upstream API was largely influenced by the one that we had with OpenShift Service Mesh, it will be a straightforward migration. By popular demand, we have also recently introduced the ability to override and customize network policy creation and management around service mesh. We know that our customers set up mesh in many different ways, and this provides more flexibility between how service mesh and Kubernetes networking work together. So by popular demand. Finally, the Quay update in Service Mesh 2.2 will come with several enhancements for viewing and navigating larger meshes, especially. We know that some customers have had challenges with Quay for viewing the very large meshes that they have, and that's something that we're working to improve over time. It also comes with a few new debugging features, such as the ability to view internal certificate information and the ability to adjust Envoy proxy log levels. Again, the ability to debug and manage your mesh. They've also shipped a new demo as well around mesh federation, which could be used as the basis for additional multi-mesh use cases. And with that, I'll pass it to next slide.
So yes, for 4.10, we have expanded the supported list of providers to include full stack automation for Azure Stack Hub, IBM Cloud, and Alibaba. So let's take a look at what we're doing on IBM Cloud. Next slide, please. So for IBM Cloud, you can now deploy OpenShift clusters on IBM Cloud for IBM Cloud VPC infrastructures. Note, we only support this with IBM Cloud VPC infrastructure, and if you're using IBM Cloud Classic infrastructure, that is not currently supported. In this particular release, we're also only supporting Cloud Internet Services DNS or CIS and not the IBM Cloud DNS services. What this means is that only public clusters can be created at the moment. In the future, we're looking to support private DNS so you can open and create private clouds in the future. One thing to note about IBM Cloud is we're only supporting IPv4 at the moment, so dual stack and IPv6 environments are not yet possible. Next slide, please. Next. So building upon the work we've done in previous OpenShift releases, you're now able to deploy OpenShift on Azure Stack Hub, which is Microsoft's on-premises cloud, using full stack automation or IPI. And so we've added some documentation for both UPI and IPI to support using customers' internal certificate authorities or CAs. On to Gaurav. Next slide. Gaurav, I think you're muted. Okay, maybe if Gaurav is not able to speak, I'll continue. So in 4.10, we are going to tech preview IPI installation of OpenShift on Alibaba Cloud. So what this means is you'll now be able to give it a try. For the 4.10 release, we will support the international portal, which includes the world and China mainland. And then please note, this is a fully connected installation with new and existing VPCs. Next slide, please. So with regards to vSphere or VMware, we now are able to take advantage of thin provisioning on your primary or boot disk that you use for your VMs in OpenShift. And what this means is the disk provisioning method now includes thin, in addition to the existing thick or eager zero thick. With thin provisioning, your boot disk will only consume the space needed and will grow as needed. And one thing to remember is that if you don't configure disk provisioning, it will default to the vSphere default storage policy. And then for NFS, it is always set to thin. Next slide, please. So in 4.10, we're introducing a new capability to enable OEM partners to pre-install OpenShift at the factory What this means is they're now able to build turnkey solutions with OpenShift embedded, or rather pre-installed on the OEM partner's hardware. This is well suited for partners looking to build turnkey solutions for rapid edge deployments. So think about use cases where you're trying to power edge workloads, where customers might want to deploy all-in-one OpenShift together with prescribed hardware to serve as a data center in a box in a remote or disconnected or even air-gapped location. Typically, these are being used to enable compute, real-time data processing, and analysis at the edge. So this solution leverages zero-touch provisioning, or ZTP, which uses a declarative specifications stored in Git repos to deploy the infrastructure using GitHub's deployment set of practices for infrastructure deployments. In 4.10, we've added documentation that will walk you through setting up the factory or management cluster, which you use to build the turnkey spoke clusters simultaneously. For folks interested in trying this out, do feel free to contact me. And let's move on to Ramon.
Thank you, June. So, bare metal. I want to highlight 3 things today about what we are doing for 4.10. And the first one, from left to right, is a long-awaited feature, which is the ability to configure the host networking at installation time with the API workflow. That will allow you to use the install config and specify per host network configurations. And something that many people have told us that they required, which is you don't need DHCP anymore. With this, you can allocate static IPs to your nodes without an external customer-provided DHCP server. So next, we are doing, or actually promoting to GA, the Kubernetes NM state. For those of you who have been using NM state, this needs no introduction. But essentially, you're going to be able to use on day 2 the NM state operator, fully supported to, again, configure your nodes just like you will do on day 1 with the same syntax, which is the NM state syntax. There is a link at the bottom of this slide to see, all the things that you're going to be able to do with NM state. And finally, another thing we wanted to highlight is the ability to update your host's BIOS settings. Now, we are adding 2 CRDs. One is the HFS, or hardware firmware settings, and the other one is the firmware schema. And what we are doing is we are collecting all the BIOS attributes and storing them in the firmware schema, along with how to use them, right? What kind of attributes and values you can set. And then you will be able, per host again, to configure your hardware firmware settings on day 2. And with this, I'll pass it over to Subin and Anand for control plane updates.
Hi, I'm Subin, the product manager for over-the-air updates. In 4.10, cluster admins will see a new feature called conditional updates. The OpenShift update service can declare in the update graph conditionally recommended updates. The cluster version operator, which will look at these conditionally recommended updates and give information to the cluster admin on what are the updates which are supported but not recommended for the cluster. Now, if you're using the OC command line tool from version 4.10, you're going to see 2 new flags when you upgrade. The first option is include not recommended. And if you use that option, you're going to see all those versions in the channel which are supported but not recommended for the cluster. And the cluster admin can now look at these data and information provided by the new option and evaluate if the risk associated with these conditional updates are okay or not okay for the current cluster. And if the cluster admin thinks that the risk is okay for the workloads, the cluster admin can now go ahead and update the cluster. And to update the cluster, you have a new option called Allow Not Recommended. So while upgrading, use this option and you can update to the version which is a conditionally recommended update. Now over to Anand.
Thank you. I'm the product manager for the OpenShift control plane, and let's talk about what are the new updates in 4.10. So let's start with Cert Manager. So Cert Manager is going tech preview in 4.10 with GA that's going to be announced subsequently. Cert Manager, it basically helps automate certificate management in cloud native environments. Cert Manager is a fully open source project. It builds on top of Kubernetes, and it introduces certificate authorities and issuers and certificates as first-class resource types in the Kubernetes API. And this makes it possible to provide certificate as a service to developers working in your Kubernetes clusters. It adds certificates, as I said, certificates and certificate issuers as resource types in Kubernetes and simplifies the process of obtaining, renewing, and using those certificates. As you can see from the diagram, it can help issue certificates from a variety of supported sources such as Let's Encrypt, HashiCorp Vault, Venafi, and even a private KPI. Cert Manager ensures that certificates are valid, they're up to date, and you can attempt to renew certificates at a configured time before expiry. And just some little background on Cert Manager is that it's based on Kube Lego, and it also has some intelligence from Kube Cert Manager. It is a fully open source project. It was developed by this company called JetStack, which was bought over by Venafi, but they've contributed this project upstream, and it's a CNCF sandbox project right now, so it's fully open source. And what we are doing is we're building a operator for using Cert Manager in OpenShift. The latest version of the upstream project is 1.7.1. And in the speaker notes, you'll see the detailed, productization, roadmap and the proposal for, onboarding this new operator on OpenShift. And you'll also see links to the latest, Cert Manager use cases. For instance, what are some use cases for the cluster admin? What are some use cases for the service infrastructure admin, service developer to use Cert Manager within OpenShift? And you'll also see the GitHub repo from where you can go use the Cert Manager operator for OpenShift. So summarizing, Cert Manager is doing tech preview in 4.10 with GA to be announced soon after that. Next slide, please. So next is around syncing group membership from identity providers. In 4.10, we have introduced support for syncing group membership from OpenID Connect providers to OpenShift platform upon login. And you can enable this by configuring the group claim information in the OpenShift container platform OpenID Connect provider. So on the right, you see an OpenID Connect CR. So if you navigate to spec identity providers, you can specify the name, the mapping method, which is claim, and right at the bottom under claims, you'll see the group information that you can provide. So once you provide the CR to the external IDP, it presents a JSON web token. Using this web token, you can obviously log into any application of it. So those are some of the control plane updates for 4.10. Handing it over to the next slide, which I think is Scott or Jeff.
Hey, so now we want to talk about how advanced cluster security has begun to streamline Kubernetes security programs over time. And the first real key need was the improvement of developer workflows. We've enabled developers to streamline risk management by giving them the ability to triage risks by either accepting that risk and getting an approval from a delegated approval authority or marking something as a potential false positive. And in this way, they can streamline CI and not have to worry about potentially a false positive or something else breaking a build that is known within the organization. We've also worked to simplify prioritization and remediation in CI. So we've given some additional vulnerability outputs and summaries for breaking builds to help developers really key in on exactly the issues that they need to address. In terms of SecOps notification workflows, we've shortened some feedback loops for vulnerability reporting to the middle management teams, but also the teams that need. We've done that by implementing scheduled reporting for vulnerabilities for standard remediation stakeholders. We've also improved our runtime notification enhancements by ensuring that we're sending detailed system information to a SIM each and every time that a potential policy violation is found in the environment. We've also enhanced the administration of the platform. As you know, ACS was the result of an acquisition. We've simplified administration of OpenShift Platform Plus through the reuse of the OpenShift OAuth authentication for ACS users. And in this way, administrators don't need to set up the same standard configuration across multiple platforms. We've also improved the scalability of our registry integrations. So for those of you who play in the AWS space and use Amazon Elastic Container Registry, we've implemented an IAM assume role to allow users to use different roles across accounts and implement authorization at scale. And I want to pass it over to Jeff.
Hey, Jamie, this is Scott. Hopefully y'all can hear me. I always love working with our ACS team. You guys are setting such a high standard and high pace, and I've recently been able to use your new OAuth on the OpenShift platform, and it works beautifully. That's one of the things we want to do here in ACM. We want to build things better together. You'll see our statement includes Ansible, includes the full OpenShift platform plus. We're diving into OpenShift GitOps, making sure advanced cluster security works beautifully, and even bringing bits of the storage at the data foundation layer up into our ACM experience. Right out of the gates, we've got a dev preview with Ansible Automation Platform that's surfacing our cluster inventory into the Ansible Automation Platform for their users to experience the OpenShift world directly at their fingertips. So the ops team doesn't have to move out of their comfort zone to start learning new things. A quick on-ramp with low entry on the skills. You'll see the highlights there about OpenShift GitOps. We're leveraging the application sets feature and bringing that to GA in ACM. Coincided with the expected GA of the application sets by the Argo CD team. That's a great way to bring applications, the application construct to the multi-cluster space. That was introduced as tech preview in 2.4, and the pace of activity moves right along into 2.5. Stronger security. See the upstream gatekeeper community working really hard to produce the enhancement around mutating webhooks. That allows us to change the resources upon their admission, giving you further control for resource admission context within the managed cluster fleet. At the same time, we're also providing improvements in secrets management, integrating variable templating that allows you to handle secrets in a more effective way, a more secure way when dropping them into managed clusters. And finally, as I mentioned before, our integration with ACS continues. We'll see policy sets dedicated to ACS, as well as that OpenShift Plus integration that brings ACM at the center point for deploying the ACS Central and sensors to the fleet. I'll take the next slide, please. So with our expected release in late April, you are going to see a cluster lifecycle for Red Hat Virtualization, known as REV, and AWS GovCloud in the US. This is awesome. It means you don't have to leave your existing infrastructure. You can be comfortable with any type of infrastructure to deploy your OpenShift clusters, whether that's on-prem with bare metal, even in the cloud, or any of the private government spaces that we're targeting, like Azure Gov and AWS Gov. As Duncan mentioned earlier, we are working hard to coincide our release with the ARM architecture support. We're targeting that as dev preview to support both the hub on ARM as well as the managed clusters, leveraging ARM for low power consumption. In particular, we see Edge as a great opportunity in that space. HyperShift. Thank you to Adele and the team that are working hard to bring HyperShift into the fold. The opportunity there to share the control plane at scale, reducing the cost, hardware footprint, and the time to position is super exciting for ACM. We're super thrilled to be bringing that to market as a tech preview and look forward to your feedback on that as well. And finally, I'll wrap it out by pointing to central infrastructure management. This has been such a fun area to work in with the assisted installer team and bringing their technology from SaaS into the on-premise space. We give you that self-service style model that allows your users, your infrastructure owners, to be able to carve up and slice up their bare metal hosts just as if it was a cloud service offering. Super exciting space for scale and growth opportunities across the fleet. And with that, I'm going to hand it to my colleague, Christian Stark, who's going to take you on to the next slide.
Thanks a lot, Scott. So finally, we have been able to provide crucial features around business continuity. So we have the RH ACM Hub Backup and Restore, using a backup solution based on OpenShift API for data protection. Managed cluster configurations can be backed up and restored in a different hub cluster. We also leverage ODF, formerly known as OCS, and RH ACM for disaster recovery across stateful workloads. For your business-critical stateful apps, ODF, along with RH ACM, will ensure you have a robust multi-site, multi-cluster disaster recovery strategy. Both ODF and RH ACM enable fast and consistent application DR that protects both application data and application state. while ODF ensures your application data volumes, BVs, are consistently and frequently replicated, resulting in reduced data loss recovery. DR operators that are enabled with Edge ACM automate the DR failover and failback processes, ensuring that your recovery is fast and error-free from manual operations. I would also quickly highlight another feature, persistent volumes replication using volume sync, formerly known as Scribe, which is also currently tech preview. It provides resilience for business-critical stateful apps by ensuring a planned application migration strategy across your clusters. You can also use volume sync to create your own DR solution when working with non-ODF storage or heterogeneous storage providers. Thank you. Next slide, please. Passing to Brett.
Thank you very much, Christian. And with Rackham Advanced Cluster Management for Kubernetes at the Edge, we're excited to announce GA of the capability to deploy and manage 2,000 single node OpenShift, that's Snow. And we're doing this in connected and disconnected scenarios. We've tested out in the disconnected, we validated 150 millisecond round trip times and 0.02% packet loss. And that's helpful for those far edge scenarios. As well, we're generating those DU profiles through the policy generator. So it does demonstrate how we can do this at scale. These are all through the zero touch provisioning, which is stored up in Git. So we're able to use the infrastructure as code by pulling it down from Git. And lastly, some exciting news. We have the ability to export the hub collected metrics to external tools. So we can give that more holistic view for customers that are needing to merge their OCP metrics with other metrics and monitoring platforms for a converged holistic view. Thank you. Handing off to the next presenter, networking and routing.
Thanks. Next slide. Yeah. So now let's take a look at some of the networking highlights in this release, right? We're extremely happy to share the support for external DNS functionality on OpenShift. Now, this functionality mainly provides the ability to dynamically control DNS records of an external DNS server via Kubernetes resources. And this is done in a DNS provider agnostic way. Now, this feature can be enabled by installing the external DNS operator via the operator hub. And this actually deploys and manages the upstream external DNS functionality. It's an in-cluster component that makes Kubernetes resources discoverable through public DNS servers. Here, we use it to synchronize exposed OpenShift services and routes with DNS providers. This is supported currently on AWS, GCP, and Azure, and is in tech preview. And going forward, we will support many more providers, including BlueCat and Inflobox. Next slide, please. Some of the other highlights that includes are support for egress IP for clusters on public clouds. Now, we could use egress IP functionality to allow you to ensure that the traffic from one or more pods in one or more namespaces has a consistent source IP address for services outside of the cluster. And this was supported on bare metal and vSphere environments. And with this release, we're happy to extend this feature on public clouds like AWS, GCP, and Azure. Egress IP setup continues to be orchestrated by the network plugins. However, they will utilize a new component called the Cloud Network Config Controller to perform the required setup on the cloud side. One thing to note is on the public cloud, the notion of a limited IP capacity per node that exists today. And it's a hard constraint imposed by the cloud provider. So this is something that needs to be kept in mind while setting up egress IP on public clouds. Another thing which we have worked upon this release is the ability to modify the MTU post-installation. During OpenShift installation, the MTU is automatically detected based on the MTU of the primary network interface of the nodes in the cluster. But as a cluster administrator, if you want to change the MTU of the cluster post-installation, be it addition of new nodes that needs a different MTU for optimal performance or any change in infrastructure, this was not supported until now. From 4.10, you can modify the MTU post-installation. The only thing to note is the nodes need to be rebooted to finalize the MTU change. Finally, we're happy to announce the support for Intel E810 NICs and Broadcom NICs that are listed here for the SRIOV operator on OpenShift 4.10. With this support, SRIOV and DPDK functionalities of these NICs can be configured via SRIOV operator seamlessly. Next slide, please. And I think it's over to Peter for virtualization updates. Thank you.
Thank you. As you all know, we're actually approaching almost 2 years now since OpenShift Virtualization, which is the ability to run virtual machines in OpenShift platforms, is approaching almost 2 years now. And we're a good citizen of the OpenShift platform. As you heard Rob say earlier, you can actually use virtual machines with Service Mesh. So to continue that, we're actually now expanding the data protection story for OpenShift itself that's provided by ODF and ACM and OADP by being able to use virtual machines that are in your cluster to show up there and be data protected just like the rest of your cluster. We're also expanding, as you heard earlier about IBM Cloud, the ability to run virtual machines in the OpenShift cluster that you provision in IBM Cloud. We're also improving the VM workflows for users and admins that are used to vSphere or Rev or even OpenStack to make them more comfortable and just get better visibility into the virtual workloads in their environment. We've also got plenty of work for GPU as well. And I really want to point out, in the past year and a half, 2 years, we've been very busy. You can see across the bottom here, we actually have demonstrated ability in every one of these areas of cloud native, GPU acceleration, modernization, and actually telco. And I'd like to just preview, we actually have a customer, Sahib Bindon, that we're going to have a success story published very soon that has actually replaced their entire virtual infrastructure with OpenShift bare metal. And they're actually migrated their 3-tier applications into this environment. It's a very exciting story. Next slide, please. So the real question is how do you actually get your workload, your virtual workloads from, say, vSphere or Rev into OpenShift? You would use MTV or Migration Toolkit. And this is actually based on the Upstream Conveyor project and now has the ability to actually do a warm migration, which is a running VM on your old infrastructure. You can actually copy the data over to a point, take a scheduled maintenance window, bring down the old application, copy the last bit of data, and bring up the new service, provided you have the networking correct, and your users will be able to move to the new platform with minimal disruption. Now I'm going to turn it over to Erwan to talk about GPU.
Hello, I'm Erwan Galen, Product Manager for OpenShift AI and Compute Acceleration. So with OpenShift 4.10, we're enabling more advanced GPU deep learning workloads. So first, we have worked with NVIDIA to bring cloud-native workloads on DGX A100 servers. So the DGX A100 server are the first 5 petaflops AI systems, so really big servers, and you can quickly deploy OpenShift on DGX A100 for testing with single node OpenShift or deploy a full cluster of DGX nodes. So we have also started to provide in OpenShift console some high-level metrics of GPU utilization, so we'll get more cluster visibility for your accelerators. If you run OpenShift on virtualization platforms as vSphere or OpenStack, we have also worked on enablement of vGPU with a more simple procedure using a driver toolkit, so no more needs of custom builds or node entitlements. As tech preview, we are also introducing new features with a new NVIDIA network operator. You can enable AI distributed deep learning training. So if you use multi-GPU and multi-node communication primitives in your code, sharing the GPU memory could be required for the performance. So as you can see in this diagram, this operator will enable the GPU direct RDMA stack. So you will be able to access data directly from one GPU to another GPU. So Red Hat has announced the GA of OpenShift on ARM for bare metal UPI. We have also worked on this topic, and the GPU operator will run on ARM system as a tech preview. Lastly, we are integrating into the GPU operator the OpenShift virtualization enablement. So you will have the option to run VMs on top of OpenShift with vGPUs, and the GPU operator will take care of the host configuration. So that's it for me, and I'm handing over to Duncan.
Thanks, Erwan. And yes, as usual, we've been busy on the Power and Z side as well. This release, we've decided to focus on flexibility, networking, and security, as you can see on the slide. I guess security is an important topic for everyone. It seems like a long time that's been the case, and particularly interesting in this release is support for IPsec, so you can take advantage of network encryption without having to make any changes to your application. Also on the networking side, we all agree choice is good. Everyone has different requirements and needs, so we're pulling in those Multus plugins that are available on the x86 side of the house, so you can choose them and decide what networks you want to attach to. And then finally, on the flexibility piece, if you're all like me, we all want a really easy life. So with the addition of these auto-scaling functionality, this release just means that you can react more quickly to changes in user demands, and that just makes for a much better, and responsive end user experience. And with that, let's hand over to Tony, who I think is going to talk to you about the operator framework.
Thank you, Duncan. So for Operator SDK, the overall theme is to help increase the operator maturity. The first notable feature is the hybrid Helm Operator SDK plugin. Compared to Go or Ansible operators, which both can reach operator capability level 5, the traditional Helm operator has limited functionality. The hybrid Helm operator enhanced it through Go APIs, so the operator authors can not only still create an operator from an existing Helm chart easily, but also continue improving it through adding event-driven logic to the new Helm reconciler in Golang to easier make it beyond capability level 2. Next, to the right, operator can create Kubernetes objects as part of their normal operations. If not properly removed, those objects could be hogging valuable resources like etcd keys or storage space. Therefore, a new library is here to help operator to remove objects specified in group version kind, also in different pruning strategies. Number 3, for an operator to run in a restricted network with DOM, it needs to list all the related images to perform their functions, and all those container images needs to be referenced by a digest rather than a tag. So the updated make bundle command is here to help easier package the operator project for running successfully in the disconnected environment. With that, I'll pass it over to Daniel for an update. Next slide, please.
Thank you, Tony. Let's talk quickly about operator lifecycle management. So you heard earlier in the Rackham announcement that HyperShift is now available in tech preview. And fortunately, OLM is there to help you with optional workloads as well. So OpenShift OLM is actually fully supporting HyperShift as of 4.10. A couple of enhancements needed to be in the code in order to remove OLM components from any of the worker nodes, such as the catalogs, and ensure that as a tenant of HyperShift, you really only see the worker nodes and need to not worry about anything else. So OLM moves these catalog components onto the managed control plane that is managed by HyperShift. For clusters that are really, really dense, that is clusters that have a lot of namespaces, we sometimes had installations that were exhibiting a lot of memory consumption caused by OLM because it had global operators under its management. And in today's model, that means that in each of these potentially thousands of namespaces, a object is going to be copied into in order to drive discoverability of the tenant via the UI, and that a certain operator is available. If that is a problem for your cluster, we actually built a release valve into OLM in 4.10 now where you can disable that copying. That will not impact any of the functionality of the cluster nor the operator, but it obviously degrades a little bit the discovery experience in the UI so that tenants can see that an operator is available to them. However, it will still function as normally on the CLI and the API level. And obviously, this is also just a stopgap as we move to a global operator model in the future where we will address this in a proper solution. For some of our products, we actually have them shipped in the form of multiple operators. And this is what we call an umbrella operator pattern. So you can see OpenShift Virtualization as well as ODF being shipped in this format. And what is important here is that users and customers stay on the supported path of all related operators. That is also the dependencies of these umbrella operators that get installed. And sometimes it was possible in the past that you would actually update to a newer version of a dependency rather than the one that you actually wanted, because the way you specify dependencies in OLM was using a flat list of requirements. Now in 4.10, we allow authors to specify and express these dependencies in more complex terms and more complex constraints using a separate language. And as you can see in the screenshot, they can also now contain custom error messages that tell the administrator that a certain dependency is missing or not at the right version level in case they are managing these manually. Next slide. Let's switch gears real quick to Red Hat Quay, our central registry for distributing images to an OpenShift cluster fleet. In Red Hat Quay 3.7, which ships alongside very closely with 4.10, we are introducing the ability to run builds on OpenShift clusters that are not bare metal. So builds, what is it? You can actually use Quay to build your container image right inside the registry. This is sort of a very easy pipeline setup where you connect GitLab or GitHub, for instance, via webhooks to Quay and trigger an image build, therefore alleviating the need to distribute, registry credentials or API tokens in your CI pipeline. The build is carried out in Quay, and previously this was done in a containerized QEMU virtual machine that was run on top of OpenShift, and then the build result in form of an image was pushed to the Quay repository associated with the build. The only problem there was that you needed a bare metal OpenShift cluster to do this because QEMU needs a bare metal machine to run. Now we have actually moved away from QEMU to a containerized builder environment, which allows us to build a container image in an OpenShift pod that is running on any OpenShift cluster on an infrastructure provider of your choice, including your favorite virtualization or cloud provider. In 3.7, you will be able to configure this via the config file. And in 3.8, this is going to be managed by the Quay operator. We're also planning some future features like the ability to produce multi-arch builds with this, so images for separate compute architectures. And we're also looking to add support for OpenShift pipelines in the future as another way to delegate build functionality from Quay to OpenShift. Next slide. And very often requested feature from Quay is to serve as a pull-through cache proxy. That means you can actually configure an organization in Quay to proxy a particular upstream registry like Docker Hub. You will want to do this when your connection to such an upstream registry is either sort of brittle and spotty or doesn't have a lot of bandwidth, and always pulling the images from the internet is kind of slow, or, which is very often the case today with, for instance, Docker Hub, the upstream registry has rate limiting in place, which you would quickly run into behind a corporate firewall when you run a CI pipeline that often pulls or attempts to pull an image from a popular upstream registry. With Quay, you can now circumvent that by making Quay cache these requests. What happens is that the client is actually attempting to pull from that Quay organization that is configured to cache either an entire upstream registry or just a certain namespace in an upstream registry. And what Quay will do is it will stream the image transparently to the client in the background while also caching the image. So the subsequent pull attempt against the cache will be fulfilled from that cache and is therefore much faster and much more resource friendly, and also insulating you from any of pull rate limiting that may happen upstream. This is also a way where you can essentially have admins allow partial access towards quote unquote untrusted community registries like Quay.io or Docker Hub without opening up the floodgates to the entire registry and allowing all images to be pulled. So you can configure the cache to just cache a certain portion of the upstream registry, and it will work. You can also limit the cache size so it will not eat up indefinite storage. And it really makes it transparent to the users because they can configure their clients to do a mirror mapping to prefer the Quay cache registry when a pull attempt against, for instance, Docker Hub's library project is performed. The picture here will be something that's possible in the later OpenShift release, where we will also have this tag-based mapping of pull attempts supported in OpenShift. Please follow the linked Jira ticket in that slide for that. Next slide is also related to storage. It's allowing Quay administrators to prevent the storage from growing ever and ever every day in a Quay registry. And we do this by showing users consumption information about the storage consumption at both the repository level, so a particular image and all its tags, and also Quay administrators storage consumption at the organization level. So as an administrator of a multi-tenant Quay registry, as you would use it in the classic OpenShift Platform Plus setup, you will want to know who is the biggest consumer of your precious storage space in that registry. And now in Quay 3.7, you can do that by just looking at the super user panel. The quota that's behind that system can also be enforced. So a registry admin can define quotas at an organization or a registry level that will limit the amount of storage that a certain organization in Quay can take up. And when that storage limit is reached, there will be no further pushes allowed until the owner of that organization actually starts to clean up older unused images to fall below the quota. To not surprise users of the registry with these kind of enforcements, there's also a notification system built in that allows owners of organizations define custom warning thresholds, which will use Quay's notification system to warn users of that organization that their storage quota is about to be fully consumed. And with that, I'm going to be handing over to another storage topic read out by Gregory. Thank you.
Thanks, Daniel, and hello, everyone. Let's have a look to what's new in storage. So with OpenShift 4.10, we are happy to announce the new CSI driver support for vSphere, Amazon AWS EFS for RWX storage access, IBM Cloud, as mentioned earlier, and Ali Cloud. We are also introducing the Azure file as tech preview. In terms of CSI migration, 4.10 includes technology previews for vSphere and Azure file. And as a reminder, these CSI drivers are automatically deployed at installation time or after upgrade when leveraging the installer cloud provider integration. It's also worth noting that the in-tree drivers are still present and remains the default class until the CSI migration goes GA. Next slide, please. We'd like to take the opportunity to give a heads up on clusters that are running on top of VMware. As I just said, we are GAing the vSphere CSI driver, and it will be deployed by default after upgrade. For clusters that are running in-tree today, the introduction of the CSI driver requires virtual machine hardware version 15. That's a requirement from the driver. Version 15 is supported by vSphere version 6.7 U3 or later. So in order to ensure a successful deployment of the driver, please make sure your cluster is running VM hardware version 15. For clusters that are running CSI today with a driver coming from an external source, because the two versions of the same driver cannot coexist within a given environment, the external CSI driver needs to be removed so that the embedded CSI driver deployment can proceed. In both cases, the cluster stability nor the performance are impacted. Checks are in place to detect this situation, and the CSI deployment will resume once the requirements are met. However, the cluster that are in this situation will be marked unupgradable to preserve upgrade stability. They can still perform minor updates, but upgrade to 4.11 will be blocked until it's solved. Next slide, please. Now into what's new in OpenShift Data Foundation. As presented earlier, we are introducing support for regional disaster recovery with ODF and ACM for failover automation. For sake of time, I won't repeat what Christian explained and move to the next slide for the other ODF highlights. So we are introducing cluster-wide encryption with Vault KMS, using a service account for at-rest encryption and better integration with Kubernetes. ODF now supports GP3 and GP2 CSI as the underlying baking storage. On the multi-cloud object gateway side, we added a capability for legacy application to write and read from the file system, while cloud native application use the S3 API, and that allows a better migration and collaboration between legacy and cloud native applications. One last important update is the introduction of a new dynamic local storage solution for single node OpenShift as tech preview. This solution has a very low footprint in terms of resources consumption and is based on the Topo LVM upstream project. That's it for the storage and ODF updates. Handing over to Rob for the Telco 5G.
Hi, folks. High-performance applications running DPDK in the case of cloud-native network functions require CPUs, network interfaces, and memory to be located on the same NUMA node. Any cross-NUMA node situation leads to a significant and unacceptable performance drop. In other words, CPUs, devices, and memory absolutely need to be on the same NUMA node. Kubelet relies on Topology Manager for container NUMA alignment, and so far, only CPUs and devices were NUMA aligned. With the addition of the Memory Manager, Kubelet can now align regular memory and huge pages with CPUs and other devices. The Memory Manager is enabled for the whole cluster by the performance add-on operator. For NUMA alignment, set a topology policy of restricted or single NUMA node, and NUMA alignment is then enforced for all containers belonging to the guaranteed quality of service class. Next slide, please. We've been aggressively strengthening our zero-touch provisioning solution for telco use cases, and we've made significant advancements in 4.10. To highlight a few, we now support deploying DUs to a CRAN hub, whether that be a traditional cluster or a 3-node compact cluster. We've added better status reporting of the ZTP status with ZTP labels. We've tightly integrated ZTP with the topology-aware lifecycle operator. We now allow for custom manifests. We have a technology preview feature for policy-driven multi-cluster upgrades. We added a feature to allow the cluster operator to sequence SNO provisioning across an ACM instance. And lastly, we added support for pre-caching images and artifacts prior to an update or upgrade so that you can download the necessary bits prior to updating and upgrading, providing as little downtime as possible when updating and upgrading. Next slide, please. It's very important for RAN DU workloads to have as many CPUs as available so that the DU deployment on an OCP node can support as many cell sectors and radio units as possible. Red Hat has been driving OpenShift's compute needs down for over a year. In 4.10, we're confident that the OpenShift control plane and the load applied by the DU workload can fit within 4 hyperthreads. The workload's characteristics, for example, the number of pods and the number of probes the control plane must manage and run, directly influences OpenShift's compute needs. On this slide, we define the application infrastructure budget as the allowable load that the application can put on the control plane. If the workload does not exceed an application infrastructure budget of 1,700 millicores, we believe that when reserving 4 hyperthreads for OpenShift, the platform control plane processes can fit within 3 hyperthreads, allowing for 1 hyperthread of headroom. Next slide, please. In 4.9, we added a node local low latency event bus vetted by ORAN. In 4.9, OpenShift supported PTP ordinary clock with ordinary clock events published to this event bus, and PTP boundary clock, but without events. In 4.10, we're now publishing PTP boundary clock events to this event bus, and we've also added Redfish hardware events to the same ORAN approved low latency node local event bus. Now telco workloads can get all relevant events when running in ordinary clock or boundary clock mode, as well as getting a better understanding of the hardware state by subscribing to this event bus. With that said, I'd like to pass the presentation over to Shannon Wilbur to review our 4.10 observability additions.
Thank you very much, Rob. Appreciate it. We're excited to announce some OpenShift monitoring additions as far as the OpenShift 4.10 release is concerned. So I'll start by highlighting a focus here on the functionality with providing audit logging for metrics. So with our ability to view now and audit which components are requesting and calling the metrics APIs, we also have enabled query logging for all Prometheus instances with support for both platform monitoring and user workload monitoring. There is support to use the Thanos querier to view which queries are frequently executing and the potential impacts the queries have on resources for performance and capacity purposes for monitoring. Next slide, please. To extend that, so some of the enhancements we offer is basically the Prometheus logging certificate capabilities. So we have the ability to improve the reliability of metrics collection. So with the new Prometheus client certificate authentication, we're able to scrape metrics and allow certificate authorities to be able to provide that. So with authentication through APIs, we're able to scrape metrics, enable reducing performance impacts on our scrape endpoints, which is really good. A lot of feedback from customers asking us to minimize the overhead from Prometheus, so we're happy to provide that. So we continue to provide our monitoring experience inside the OpenShift console, which I'm going to talk about here in a minute, where we're going to go through and highlight some of the workflow and integration inside the OCP console and some of the capabilities you can expect. Next slide, please. Our improved OpenShift monitoring UI experience. So what we're really focused on here is really delivering that in-cluster monitoring experience where we can start to bring together the value add of rather having a distributed management experience of different assets and components from Prometheus to Alert Manager into scrape endpoints. We're pleased to announce that now in the OCP console, we're able to provide a more native and coherent user experience for administrators and developers. So in 4.10, we've enhanced our user experience to bring together alerting and metrics into the OpenShift console. So basically, integrated Alert Manager under the Observe and Alerting menu from integrated Prometheus user experience for the metrics-specific menu. And then also, I'm going to highlight on the next slide is integrated scrape endpoint targets to observe targets, which is going to be another enhancement. Next slide, please. So this is a key feature that is intended to provide a lot of value and reduce a lot of the administrative overhead. So we have new Prometheus target endpoints inside of the console under the Observe menu, which allows us to observe and manage all of our scrape endpoints as one entity under the OCP console, versus in previous releases having to individually manage those independent and those individual targets. That gives us a lot more ability to look at the aggregated view of our scrape endpoints and be far more efficient there. Next slide, please. So for OpenShift logging for 5.4, we continue to evolve our strategy for our Loki logging stack with OpenShift. So we're offering our capabilities to extend Loki and the vector logging connector. There's been a lot of high demand and a lot of community about Red Hat and the OpenShift team moving into the logging stack for Loki and the vector collector. So we continue our tech preview phase, and we're working towards working with our customers on our use cases and providing that capability, and essentially looking to extending Loki and Prometheus support in the future into next year, but also taking advantage of all the performance impacts and capacity across Loki and vector going forward. So with that said, I will pass it off to my teammate, Maltron Leal, for distributed tracing.
Thanks a lot, Shannon. For distributed tracing, one of the technologies that probably most of you is already familiar, it's based on a Jaeger. As OpenShift 4.10, we are releasing this distributed tracing data collections, which is pretty much based on OpenTelemetry collector. And what it's going to do is it can act as an agent to work side by side with your application, or even it can work as a gateway to get connected to existing backends on OpenShift, but also outside of OpenShift. Eventually, we're going to release other presentations to explain more further and deep about the OpenTelemetry collector, so stay tuned. With that, I pass the baton to the next PM, Radek.
Thank you, Maltorn. So Insights is a set of services that we offer to all OpenShift customers for free on console.redhat.com, and they provide additional experience with managing your cluster infrastructure. One of these services is called Advisor, and it's all about proactive support, giving you recommendations about potential issues or existing issues and specific remediation steps how to avoid them. With 4.10, we're delivering and bringing to you a new user experience with the Advisor application. New View allows you to look at all available recommendations for the set of your clusters, and also being able to filter them out, disable recommendations that are not interesting for you, not interesting for a specific cluster, and do additional views on these recommendations that are available. With this new UI, we're also delivering an onboarding tour that you can easily walk through all these available features. As part of this, Insights also delivers a new feature that was already mentioned by my colleague here to enable simple content access for Red Hat content. And together with this new feature, you'll be also able to see an OpenShift Cluster Manager, your support status, whether your cluster is supported on which level, and whether your EVAL expiration has already been due. All these features are already available in console.redhat.com/beta, and they will be GA'd with 4.10 very soon. Another service that is available to you is cost management, and Sergio will talk about it.
Thank you, Radek. So cost management is a SaaS offering too, part of Insight that we are offering to our OpenShift customers, that it's basically provide visualization of cost and metrics for any cluster that is available there. One of the things we do is we mix that information with the bills coming from the clouds. And one of the improvements we've added to 4.10 is the capability to use saving plans. So before, when you had saving plans, we were just use unamortized values, and some customers needed to see the amortized or the blended values to get accurate numbers. Now that support is provided for anything that is Amazon related. Another thing that we were being asking a lot is increasing the number of days that the information is available. So from 4.10 on, you will have at least 90 days. So you will be able to go to the cost explorer and select more than this month and the previous month. That was what we were supporting before. And another thing that has been really a request by customers is the support of OCP on GCP. So we support Amazon, Azure, and Google as underlying infrastructure clouds. In the past, we were supporting the distribution of cost of those clouds into OCP concepts like metrics or tags. With this release, we add the same functionality to GCP on OCP. So we have parity in the three clouds that we support. And the last thing is we are actually modifying the way we are calculating things. One of the things we do is we distribute costs based on CPU or memory into your projects or tabs or nodes. And we had the thing that you could use they use all the requests, but actually customers were saying that they use it's never going to be below the request because the request is a reservation. So whatever they have a cluster where the use was very low and the request was high, the numbers that we're seeing was not reflecting reality, nor use or request separated will allow them to see what was going on. And now we are adding this capability. When you created a resource, when you're creating a rate plan, you can select the effective usage, and we will select the maximum of usage and request. So every time you use it, the minimum will be the request, and the maximum will be the actual usage. And that's all for cost management. And I think I'm the last one. So this is the last slide.
Yes, thank you. Thank you everyone for joining. I hope you learned a lot about new features that you want to take. I want to give you a reminder that at learn.openshift.com, you can check out guided demos of all these types of features on a real cluster. When 4.10 is out in mid-March, that will be updated. Right now, that has a bunch of cool stuff that's going on in 4.9 and earlier versions. As always, you can find more OpenShift information, documentation, more at cloud.redhat.com. And I want to call out, we have a new database gathering coming up in OpenShift Commons. This is our user group where folks can learn from each other about how they're using OpenShift successfully. That is on February 23rd. And if you're watching this recording after that date, go check out the video of that as well if you use databases on OpenShift. Thank you so much. Hope you enjoy OpenShift 4.10 in mid-March, and we'll talk to you next time.